we are recording. The reason I'm making this video is because all businesses are very bad with data, and that's big and small businesses. So recently I had a guy come to me and he asked me about his Google Ads account. He said something's gone wrong and he doesn't know what exactly has happened and nobody else really knows what's happened. And you can go back and forth and have a conversation about what you think it is. And I ended up asking him, I was like, do you have somebody that is like data centric on your team? And he just goes, no. We've got a couple of marketing people. He doesn't really trust that they know what they're doing. And I explained to him that what I will do for him as like a friend is I just come in and I just follow this process, kind of hinting that anyone can do this. The process that I'm talking about actually comes from management consultants and they love it. It's called MECE, right? So what MECE is it's an acronym and it stands for mutually exclusive, collectively exhaustive, right? So you can see that is just like MECE. Now, together they mean one thing, but split apart into ME and C, they mean two different things that you're supposed to add together. So what does mutually exclusive mean? Mutually exclusive basically means that something has to be something or something else. So let me explain that a little bit better. You have this block, right? And we split it like this. And we measure these things over the spectrum here. Let's say that for this purpose, it's going from like 0 to 100, which is the end of this arrow. You can see that when you hit any point of this little line here, if you go across here, cross here, cross here, cross here, cross here, you're inside A or you're inside B. And because there is no overlap between A and B, you actually have mutually exclusive components. So A can never be B and B can never be A. But if I went and I did something sneaky like this, if you go to this part of the line here where A and B cross over, exactly like a Venn diagram works, you can see that at that point of the line it's A and B, which means it's not mutually exclusive. Now, why mutual exclusivity is very important is because it makes things easier to diagnose problems, right? So if I take a set of data, I don't really need this audio data thing to begin with, I did that just to set up. If I take your entire set of data, which is A plus B, and I really look at it and I say, well, where does the problem lie? And then somebody goes, well, if I look at these two things separated like this, I'll say that the problem lies in A. You go, that's great. What we do now is we just never look at B again. Now we just focus on A. Now, even when running through this process, you'll find that some business owners will agree with you and they'll be like, yep, the problem is in A. And then they'll actually, kind of like the screen is moving, they'll start going on to this other side and they go, but, I was thinking, and then they just turn all their focus onto the wrong thing again. And if you're really good at data and solving problems, you have to be a little bit stubborn and keep everyone onto the fact that we all agreed that the problem was in A, so we're going to get to the bottom of the problem only focusing on A, right? Cool. So that should give you somewhat of a conversational understanding of what mutually exclusive means. We'll leave these colored like this for now. What's collectively exhaustive? So let's say we have, like we said, this is 0%, we'll call it. It's connected there. And then this is 100%, right? So now what's happened here is collectively exhaustive means that the sum of all parts equal 100%, right? So let's say that, like AB here, for example, if I draw that all the way over to 100%, let's assume that's lined up, then these two components are all of your data that you're observing. This is a collectively exhaustive set of data. Now, if I make A smaller, let's say, and then B's the same size, let's say, we can see that there is a gap here, right? Which probably needs to be filled with some sort of third set of data. So the way to think about collectively exhaustive is to think about how exactly really good management consultants pitch segmented data. And their favorite chart to use is actually a pie chart. So if you can imagine drawing a pie chart, you can't actually draw a full circle until you fill the circle. So normally, let's say that this was a breakdown of costs, right? So this is supplies and labor. And normally what happens is people get really confused on this last one because it involves so many things. You know, you've got rent, you've got utilities, you've got miscellaneous expenses. And the best way, if you're going to fill in a pie chart, is to just go other. So that way, other is a catch-all to make everything collectively exhaustive. Because if you go through here and you go, well, our problem is not supplies, and our problem is not labor, so our problem has to fall somewhere in between other, what you do is you actually just bring that down and you consider that to be your new 100% of data. And then what you do is you go, before going through this complex categorization process for all of these weird variables that you have to really find out about, this is the point where you start going, well, we thought we could get away with dealing with these larger chunks that are easy to categorize, like supplies and labor, but now it looks like we're going to have to split other into mutually exclusive, collectively exhaustive components. Probably what I didn't do, which is what I was planning to do before I got sidetracked there, was explaining how they work together, right? So let's just do this. Okay. So this set of data, we'll call it A, B, and C again, is mutually exclusive because none of the parts overlap, and it's collectively exhaustive because all parts add to 100%. So you can see here that if I do that thing again where I shrink B and I take C down, these are all still mutually exclusive because they don't overlap, but there's this big gap here, right? And that makes it not collectively exhaustive. And like I said before, what you do there is you categorize something, another variable, as deep or other, right? Now you're back to being mutually exclusive and collectively exhaustive. But you could also do something like this, where things are collectively exhaustive, but they are not mutually exclusive. Because what happens here is you could go to this point here at about the 55% mark, and you say, well, this is B and C. And you could understand that if your problem lies somewhere in between this threshold, it's very hard to diagnose where exactly the problem is when you've got two potentially mutually exclusive components that you're dealing with, right? So the best way to do that is to maybe recategorize how you're thinking of things. So, you know, what's something that's pretty hard to categorize? Let's say you're doing ice cream flavors, right? And you were like, everything that is vanilla is here, and everything that is chocolate is here, but here you have choc mint, which is mint and chocolate, if you know what I'm saying. So you're actually doing a little bit of crossover there. So what you could do is you could actually say, well, this is any flavor that contains chocolate. Remove the choc mint and drag it across there. And therefore, you're going back to having stuff that is mutually exclusive and collectively exhaustive. So let's go back to my friend that had the problem. I don't know what his problem is. And data doesn't always give you the answer, but if you have a very good set of data, you actually end up finding the problem very easily. So I told him, I go, all I'm going to do is I'm going to get your data, and I'm going to analyze it very slowly, but I'm going to make sure that it is mutually exclusive and collectively exhaustive at the top. So let's say it's like A, B, and C. And I'm just going to pinpoint where the problem is to begin with, because it's going to be pretty clear when you segment where the problem is. And let's say it's B, right? So now B comes down to this new point, and then we steal this spectrum here, and we just go, all right, well then you've got, this is not going to play nice, but you know what I mean. Let's just say that B is 100%. But now what we have to do is we have to go, well, how can we split up B? And you go, well, you've got bananas in pajamas, B1 and B2. And then you just quickly determine where the problem lies again. And you just keep going down. You're just drilling, right? And eventually you'll come to this point where you're like, well, B1 is where the problem lies, and I cannot split it up anymore. So there's something in here that's telling me that there's a problem. Now, this is all about problem discovery. I'll talk about solution design and implementation a little bit later in another video. But hopefully this helps you understand that the best way to trawl through data is very slowly, just get a lay of the land and then just dive deep, just slowly. You don't have to run before you can walk, and you can see that already you can go from A to B to C, and all these things mean nothing to me, nor should they mean anything to you, but then you just like stop focusing on C and stop focusing on A. Like, it's going to waste your time. But when you go down to B, find out what else wastes your time. Find out what else wastes your time. And then you get rid of B2. And then you're just left with this glorious detail here, which is B1, and you go, all right, now we know where the problem lies. We can start identifying what the problem is and then defining the solution. Hope that helps. Let me know if you have any questions. Bye.